All right, in this lesson, I'll introduce the pivot method, which is used to basically reorient a data set. It's used to take the values that are currently in a column and basically convert them to column headers. And I'll show you an optimal example and where you might want to use this in real life in just a second. Now, this doesn't really have to do much with multi-indexes, but it does have to do with reorienting data, which is the larger theme of this tutorial. So I thought that I'd fit it in within this module, as well as the upcoming lessons on things like the stack method and the unstack method, which also sort of deal with multi-indexes, but are also concerned with kind of shifting data from point A to point B. So we're going to be using a fresh data set here for this one lesson, and it's called salesman.csv. So let's call our read_csv method and take a look at this file. So basically we have three columns here. We have a date, we have a salesman name, and their fictional revenue that they generated for our company. Now the first thing I want to do here is ensure that our date column is actually being rendered as date time. That's just keeping with best practice. So I'm going to provide that parse dates parameter here and just give it a list of strings for the columns that I want to render as date times. So I'm just going to put my date column right here. And there it is. And now I'm satisfied, so I want to store this in a sales variable. I just want to preview the first three rows. There's one other thing that I'd like to do here just because we can. So this data set, if I just take a look at it with the len function, is 1,830 rows. But as it turns out, if I just go to my salesman column and take a look at the value counts method, there's basically only 5 unique values in that column. 5 salesmen: Bob, Dave, Ronald, Oscar, and Jeb. So each one of them has 366 values. So basically it's a year's worth of fake data for these salesmen, how much they generated on a day-to-day basis. So there's a very small number of unique values in my salesman column, so it's the optimal column to convert to a category. So I'm just going to do that just because it is optimal. So I'm going to take the salesman column, I'm going to extract it here on the right side as well, and just call that as type method and provide it an argument of category. So now we basically have everything in its best shape. So as I mentioned, this salesman column is basically repeating the exact same name over and over and over. It's going Bob and Ronald, each one of them, 366 times. And we thus have a data set that's 1,000 and, 1,500 or 1,800 rows long. It's not really the most ideal format sometimes to store this data. What we really need to do is to pivot it to a format that's probably a lot more readable and that saves us a lot more space. So what would be better, of course, is if we just took that salesman column there in the center and took its values, and there's only 5 unique values there for our salesman, and placed those basically on the top as our column headers, and then put the revenue values as the values for each one of those names. That would basically cut out a lot of space from this data frame. So let's take a look at how we might do that, and once you see the final result, this will make more sense. So what I want to do here is call the pivot method directly on my data frame. So we're going to do sales.pivot and open our parentheses. And you can see it takes 3 parameters: index, columns, and values. And predictably, those are just asking you what you'd like to serve as the index, the columns, and the values. So the index, which is going to be this thing on the left in bold, of course, we can keep that as our dates. We have no problem with the dates being listed as the horizontal index label. So for the index parameter, I'm just going to give a string argument of date. So all the arguments to the parameters here are basically going to be the column names from our original data frame. Now, the next parameter here is columns, which is asking what column from the original data frame would you like to use as the values that will comprise the new columns in this new data frame that it's going to render for us. So this is where I want to put that I want to use the salesman column. Keep in mind here that in this case we have a perfect data set because we only have 5 unique values in the salesman column, but the more values you have, the more additional columns will be created in our new data frame. So this is really only an ideal operation when you have a small number of unique values in a specific column. If there's a unique value such as like the date column, that would be the worst thing that you could put on for the columns parameter, because it's just going to create a separate column for every date and basically wreck the whole purpose of condensing our data frame. So we have the index, it's going to be our date. Our columns are now going to be our 5 salesman names: Bob, Ronald, Jeb, and so on. And now the only thing we have to do is specify what are going to be the values at the intersections of those row labels and those column labels. So at the intersection of every date and each salesman name, which is our column, we want to actually put the revenue they generated. So for the values parameter, I'm going to put my remaining column, which is revenue. So now when I execute this, I'm going to get a brand new data frame. And you'll notice that the columns have basically completely been mixed around. There are no more date columns or salesman columns or revenue columns. The values from the salesman column, as mentioned here, have become our 5 headers right here. And their appropriate values from the revenue column have become the values in the center of the data frame, with our index being the dates. So for example, if I look at these 3 rows for Bob, we can see that his revenue on January 1st was 7,172, followed by 6,362, and here are those 2 values for those proper dates for Bob. But instead of having those same 2 dates repeated for every other sales rep, for Dave, for Jeb, and Oscar, and Ronald in the original data frame, I now have them all represented on the same row for the same date. So I've basically shrunk this data frame by 80%, because for every 5 rows that used to exist, I now have 1 just for that commonly shared date. So you can see how the pivot method is particularly effective for condensing a data frame by kind of aligning on common values. I can even prove this, in fact, by simply taking this and passing it into the len function. We can see that it is, in fact, 1/5 of what we just had. So just to summarize again, this pivot method is called on a data frame. You provide it an argument for the index that you'd like to be in your new data frame, what columns from the original data frame you'd like to serve as the new columns in your or rather the values from what column in the original data frame you'd like to serve as the new column values in the data frame that's going to be generated. In this case, we chose the salesman column because we wanted those unique values to be our new column headers. And finally, for the values parameter, you choose the column that you want to have the data aggregated by or kind of aligned by. And that's the pivot method.